All right, welcome Math 10C students. This is our second week of online schooling. Definitely missing being in the building with you guys, but this is kind of the second best thing. So we're starting the 5.5 lesson today. 5.5 lesson is all about the graphs of relations and functions. But before we're able to start that, we have to do a little bit of review of inequalities. So you've looked at inequalities in previous math courses. We can use these different inequality signs to compare two qualities. So the symbols that you need to remember are these four right here. Okay, so the first one, again, you'll notice that it's facing away. That is a less than sign. The other one, you'll notice the bigger part of it is facing towards. That's the greater than. The next one is less than or equal to. Again, the difference between that and the other less than is you'll notice that there's a line underneath the inequality sign. And then the last one there is greater than or equal to. Again, you'll notice that there is the line underneath the inequality sign. So remember that the symbol always points towards the lesser number. Okay, so we can take a look at a few examples here, and then we can try some of the bottom ones. Okay, so the first example here says A is greater than 3. So again, that means that with the A and the 3, the big part, it's kind of, I like to think of it like a crocodile. So the crocodile is going to eat the bigger of the two. Therefore, it's facing towards A because A is the greater of the two. The next one says B is less than or equal to 7. So again, you'll notice that now this time, the bigger part of the crocodile mouth is facing towards the 7 because the 7 is bigger than the B, and this is a less than or equal to, so again, it has that sign underneath. Now, a double inequality is just two inequality signs in one statement. So you'll see here there's a few examples here. They suggest in these, and I do too, to break it into two parts. It makes it a little bit easier. So break it into two parts and then combine it together. So this equality says G is greater than or equal to 5 and less than 11. Okay, so they broke it into two statements. G is greater than or equal to 5, and they wrote that here. They also broke it into another statement and said G is less than 7. So they wrote it like that. And then they can combine the complete statement together. Again, when you do this, your variable should be in the middle, okay? So when you combine the statements, make sure your variable is found in the middle. All right, so let's try a few inequalities together. These ones down here, we'll do the check together so you can kind of do it with me as we go through. So it says use a symbol to write an inequality for each of the statements. So the first one, C is less than 6. So again, if C is less than 6, that means that it should be facing that way because again, the 6 is greater than the C. The next one here, D is greater than or equal to 0. So that means that the D is the bigger one, that should be facing the D. It's greater than or equal to, so we need that little line underneath. For C, E is greater than -2. So again, E is greater than -2. And then the last statement here, F is less than or equal to 4. So F is less than or equal to 4. Okay, that's how you would do those ones. Now at the bottom here, they've asked you to write some double inequalities. And again, they suggested, just like they did above, to break it into two parts. That just makes it a little bit simpler. So let's break this one into two parts. It says G is greater than 2 and less than 10. So let's start with the first part. G is greater than 2. So G is greater than 2. Another way we could write this is 2 is less than G. Okay, and then we need to write the second one. So G is less than 10. So G is less than 10. So we're going to take this one here and this one here and combine it into one statement with the G being in the middle. So we have 2 is less than G, which is less than 10. Okay, so that's how we would write the complete statement. So I want you to try this next one on your own. Again, if you want to pause the video here for a minute, try the next one on your own and I will put the answers in after you have paused it. So please pause now. So again, note that we used those two to make the complete statement. Okay, so we're going to move ahead to the next video. Okay, so we will continue on the next page, which is page 280. So we're going to be looking at graphs of relations and functions. So on the graph of a function, so these are kind of the key things. You should be making sure you write these down if you didn't print off these notes. So on the graph of a function, any vertical line will always pass through no more than 1 point, okay? So you can see in this graph here, okay, that if we were to join these points, okay, there's no spot where a vertical line would pass through more than one of them. So I could, anywhere on this graph, just draw some vertical lines. There's a vertical line. Oh, didn't pass through more than 1 point. Here's a vertical line. Okay, so anywhere on this graph, if it is a function, if we draw a vertical line, it shouldn't pass through more than 1 point. That's really important. If we look at a graph of a relation that is not a function, then we might have a vertical line pass through more than 1 point. Okay, so it's not every single spot on this graph, but there could be one spot in particular where a vertical line might pass through more than 1 point. So if we look right here where that dotted line was drawn, oh, that vertical line passes through more than 1 point. That means that this is not a function. Whereas the graph on the left-hand side, this was a function. Okay, so we can use this vertical line test to tell whether something is a function or not. Okay, so here's the instructions here for the vertical line test. You need to place a ruler vertically on a graph, slide the ruler across the graph, and if one edge of the ruler always intersects the graph at no more than 1 point, then it is a function. Remember, if it passes through more than 1 point, it is not a function. So let's take a look at these two graphs below. Okay, if you have a ruler, that would be great. You could even just use a piece of paper. Sometimes you can even just eyeball it. So if we look at this first graph here, okay, if we were to draw a vertical line at any of these points, so we could draw one here, we could draw one here, 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 here. Again, we'll notice it does not pass through more than 1 point. So we would call this graph a function. If we take a look at this other graph, let's do a vertical line test and see. Okay, only 1 point here, 1 point here, 2 points, okay? Since we passed through 2 points here, this makes this not a function. Okay, so because, again, due to our vertical line test, at 16, we passed through 2 points, that means this is not a function. So I'd like you to try this check on this page. You can pause the video now. I'll just be filling in the answers as we go. But again, use your vertical line test to figure out if these are functions or not. So I'm going to take a look at A. Again, if I draw vertical lines through each of these points, I know, sorry, I don't have a ruler. You really should. Okay, is there a vertical line that passes through more than 1 point? No, there is not. So the graph does represent a function. Taking a look at the graph in B. Everywhere there's a point, I'm going to draw a vertical line. So no, no. Oh, yes. Okay. So is there a vertical line that passes through more than 1 point? Yes, there is. So it does not represent a function. Okay. So that's very important. Vertical line test. Some of you might not even need to draw vertical lines. You might just be able to look at it with your eyes and see anywhere where there's a vertical line, would that be a function. So a couple important terms here. It says when the points on the graph are joined, so you might remember from the previous video, oops, sorry, a little blurry. From the previous video, we call that continuous data. Okay, we can use inequality symbols, so the ones that we previously did, to write the domain and the range. Okay, so we can only do this again if this is continuous data, if the points on the graph are joined together. So let's take a look down below and see how we would write the domain and range for these two examples. So it says find the domain and the range of each graph. As a review, the domain, those are the X points that we're looking at. So kind of where does the X start, where does the X end? And the range, we're looking at the Y points. So where does the Y start and where does the Y end? So if you remember, we started with this fancy looking little bracket here. Okay, so let's take a look at our X points. Where do they start? Okay, well, it starts at -2 and it goes all the way to a +2. Okay, and the X you can see here at this point is equal to -2. So we would say that -2 is less than or equal to X. Okay, because it can be equal to that, but it also can be in between that range or in between that number. And then if we look at 2, well, it's actually on the 2 point. So that also means that it's less than or equal to +2. Okay, so you can see from this that it shows our domain here of points anywhere from this point all the way up on that line to this point. That's kind of our domain. So that's where the X could possibly lie. If we take a look at the range, if we look at our starting point, our lowest point on the y-axis is at 0. And our highest point on the y-axis is at 6. So put my y in the middle there. And again, I'm going to do a double inequality for this one. So we could say that 0 is less than or equal to y, because again, it can be equal to that, to the 0 point. And y is less than or equal to 6. Okay. So again, that's our domain and range for the first graph, for graph A. Let's take a look at graph B. Here it tells us a dot at the end of the graph tells us that the graph stops at that point. No dot means the graph continues. So you'll notice that this one had a point at the beginning and a point at the end. For B, it has a point at the beginning, but it does not have an end to it. So we're just going to write this one a little bit differently. Okay, so again, what that means is that the graph could possibly go past this point off of our drawn graph. Okay, so let's start with our domain for this one. Okay, so again, domain, we're looking at our X. Now, this one does not have a double inequality because you'll notice that this is our starting point, but from here, it could continue on anywhere in that direction. So this one, we would say X is greater than or equal to -2, which is our starting point. Now let's see if that's accurate. So it starts at -2, and it could really go anywhere on the x-axis beyond that. Okay, that looks right. And with our range, again, since we don't have 2 points, we just need to do this as a single equality. So y, if we take a look, our lowest point of y here would be -2. So that means that y is greater than or equal to, sorry, -1, not -2, -1, okay? So it's greater than or equal to -1. So that would be our domain and range for these graphs, for these functions. So I'm going to suggest at this point that you flip over the page. Okay, we already did the example together, and that you do the check on the bottom of page 282. You can check your answers later using the answer key that I posted on the Google Classroom. Okay, so for the last part of this lesson, we're going to look at finding values from the graph of a function. So they've given us here a graph of the function y equals f of x. So in the first part, they've asked us to find the range value when the domain value is 2. So the range value, okay, so we're looking for the range value here in this question. And the range value, excuse me, is a value of y. So we're trying to find when our domain, or when our x, right, when our x equals 2, what is our y? So let's take a look at the graph. When x is equal to 2, y is equal to 5. Okay, so that means that our range value is 5. Okay, let's take a look at the next one. So it's asked us for our domain value when the range value is -3. So our domain value will be our value of x. So when our range is -3, that means when y is equal to -3. So let's take a look here. -1, 2, 3. There's our point right there. So you can see if you look up that our x value, okay, so in this case, our domain value or our x value is -2. Okay, so our x value is -2. So at this point, okay, we just went through the solution to that, so you don't need to do that part again. I'm going to suggest that you spend some time working on the check on page 284, as well as the practice questions on page 284, and that goes all the way to 286. And again, remembering that these questions within the booklet, just as we would do them in class, I'm not taking them in for a mark, but they're helping you practice the skills so that when we do get to the summative assessment, you've had some time to practice and you know what you're doing. So you can stop the video now and go on to complete the check and the practice questions for the remainder of the 5.5 lesson. Have a great day.